server side, we send our payloads to the server, and the server sends us back a new representative tree of objects. And it's very easy to flush these objects down to the UI, and also maintain any kind of like front-end state you need. So that was our thought then. So instead of saying that rewriting to an ambitious web app, we are not doing that. We are actually building a maintainable web UI just for screening portion, and we are really writing on top of our app and not rewriting the app itself. So some other reasons. When we first started our project, we had a really small team. It was just me and another developer, Tennyson, and both of us were situated in Singapore away from the rest of our team. So during that time, we already knew that like Ember's training and onboarding process is a little bit steeper. Like there's, you need to spend a little bit more time to get productive, versus like the morale boost of like immediate productivity. I didn't want to spend any time training Tennyson. I just wanted him to start working right away. So React seemed to be like a better choice then for this. So the ecosystem, oh shit, I'm doing too much JS. It's like, React has a very strong engineering teams, and a lot of them are contributing libraries. So I saw very good users like Airbnb, Flipboard, everyone contributing libraries to the React community. So that was a very strong sell for me because I believe that these libraries will be maintained well. So I will spend some time at Laundromat every week. It has a Wi-Fi hotspot, bare minimum connectivity, like loading a page takes 3 times longer than normal internet connection. And I would use that time that I would wait for my clothes to go through the whole cycle to try rewriting a part of the app in React versus Ember. And what I found out was that I actually could go a little bit further in Ember because there's some constructs around it, like trying to make an index page that reuses client-side data to render each item was very easy to do in Ember in a way to start. But I actually felt much better doing it in React because when I was frustrated by Ember, I couldn't find any answer to it. But React, I could always write some bad code to get out of it, which gives me a chance to learn like what was the reason why I couldn't do something, and eventually like maybe refactor this code to better code. So I was hitting up against the wall a lot with using Ember. So this kind of like final point kind of like cemented the idea that we will use React for our app. So we started off in early Feb 2015 with a very simple stack. We use Webpack, React, and we use Reflux. So I guess like Reflux is no longer so popular, but during that time it was the first kind of Flux library that made things easy to integrate and use. That's way before Redux came out. So we started using Reflux, like, oh, this gets rid of some verbosity of the Flux library. Yeah, we're very happy about it. And then of course we used React Router because it was like kind of the canonical router around, and Super Agent to do Ajax requests, which we are deprecating with like simple fetches. So seeing the famous Flux diagram, you see like, oh, yeah, cool. Yep, you view dispatchers and action, the dispatcher returns the data to the store, everything works. But essentially, how do we do very simple things like handle server Ajax requests? How do we deal with entity data? Do we normalize them, or do we like keep them in stores everywhere? What do we actually store in the stores? It's like, up to this point, I still don't know exactly like what is the right thing to store inside the store. How do we organize codes and do simple things like validation and display error messages? So Reflux kind of abstracted away the dispatcher, right? And we had our own kind of architectural diagram. React Router is the like kind of starting point of it because you hit a URL, view components get rendered, you dispatch actions. It will either hit the Octopus. Octopus is the code name for our server-side app. So you either hit an API endpoint and dispatches the action back to the store, or sometimes there might be like push actions, like using pusher or WebSockets to push actions back to the source. But this was essentially incomplete in a way because we dealt with entity data a lot, and the biggest entity data we had was the candidate model. Like there's candidate ID 13 is a person, the person is called Damon. There should only be one copy of him existing in anywhere in the state. It shouldn't be duplicated anywhere at all. That's kind of our thinking, and that's kind of what we saw people talking about in the React community. Like, for example, if you duplicated Damon everywhere in all the different stores, and you had a typo in his name, and you wanted to change this typo, how would you use Pusher to do that? You have to change the data in all these places, or find some way to have a single common point of changing the data. So we came up with this small little abstraction we call the warehouse, lack of a better name, because we wanted to call it a store, but store is already taken by stores. So what this warehouse does is, wherever you dispatch an Ajax request, it is the first responder to the Ajax request, and will pass based on conventions like the keys of the name, like candidates will get put into candidate store, stages will be put in stages store, the interview will be put in the interview store. So it will do all these things and put the entity data in the right store. and then notify the stores to trigger dispatch. So we did this so that we can continue keeping the one-way data flow, but add a little bit of abstraction to help us with things. So this is a slide covering it. So it's like everything is a POJO, and it exposes very simple method for finding and updating things. So it is as simple as, right, if we were to find a record, I wonder if you can highlight here. Okay, it doesn't work. Yeah. So if we were to find a record, all it does is we have a data which is a simple POJO object, and it's ordered by ID. So you could pass in the ID, do the data hash, and get the record back. You could do things like receive a record too, which is something that we do, and we'll merge the two records together because we never delete stuff, so it's easier for us to say, hey, whenever we receive new data, just merge them together. It's okay to have stale data on it because if the data is supposed to change, the server side will return it. So we always are able to merge the two records together. So just a little bit on testing and deployment. So with this, right, we have our basic app going on. We started making like little Flux Flux actions and stuff, but we didn't know actually how to test all these things. So first to talk about deployment, right, we have to put the deployment somewhere. So we have a very simple flow. Well, the doc is the developer, so he merges the PR. It goes to on GitHub, and it goes to Circle CI, which is our continuous integration service. So that will run all the tests. Like we never let production tests run on local machines. Like if we're testing against a build that's going to go to production, it's always tested on Circle CI. So it's a common way of testing. So if it's green, it'll go back to GitHub, and we'll call a deploy hook, which is the integration between Heroku, GitHub, and GitHub to like tell Heroku that, hey, you can deploy this app now. So we'll push the code to Heroku. And Heroku will use the post-install hook to run our script. So our script is basically called build. So we run like npm run build. And this is the thing that compiles Webpack assets. And you get the index, bundle, files, styles, and assets. This is actually the essence of our app. Like there's an index HTML file, there's a bundle, styles, and some images, assets, and that's it. Right? Because it's a client-side app. And then it will be served by Nginx using Heroku static build pack. It's something we found online that works very well for us. It also does like dealing with proxying AJAX requests to deal with like cost problems and stuff. So shameless plug, I have a blog post on it. So then back to testing, right? Like how do you test a classic single page app? Actually, at this point of time, I'd like to ask if anyone like found a good strategy testing React, other than using unit test. Yep.
Like shallow rendering.
Shallow rendering.
Render the component without like rendering all the way down.
Cool. Yeah, we do some of that too. So, any other testing strategies for single page apps or server-side JS apps? Right. So what we found was, in terms of stack, we use a few different tools. Like we have Mocha, Chai, and Sinan. So because we believe in the micro libraries approach, we believe that we could use everything. So we started with Mocha, and we realized that, oh, okay, Mocha has a few things, but doesn't have a lot of things. So we use Chai to get our nice like expectation syntax. And then realized that, oh, you have to do certain mocking and stuff, and we imported Sinan and a bunch of other libraries to actually integrate them together. And we used Karma as a test runner for using Chrome. We started using Phantom.js, but just gave up on Phantom.js because there was a lot of times like function.line doesn't work and stuff. I was just like, hey, I thought this is supposed to be a full ES5 implementation. Why don't we just use Chrome and maybe like run slightly slower tests? And that was actually okay to live with. By the way, like I think Chrome is coming out of the headless mode, so we could start running tests without the UI. Then we have Protractor for running our acceptance test. I think this might be one of our biggest mistakes using Protractor because it was kind of like designed for Angular in a way that we had to like turn off a lot of things to make it work for React, and it never felt very natural to do it. So sleeping at night is pretty important to me. So these are like a different set of models of domain logic we have. So on the back end, we have like our models which are covered by unit tests, controllers by controller tests, and we have our AJAX endpoints. And we kind of cover these endpoints by using request specs. We like request specs a lot because they just test the endpoint from start to the end. If you can get a request to serve you the right data, you could kind of say that you covered the whole app stack in terms of the backend. On the front end, we have like unit tests for stores, actions, and components, like including shallow rendering. But that little bit of gap between integrating the front end and the back end was actually when most of our failures came from in the early stage. Like someone would change something, the endpoint would change, and no one knew what was happening. The app started breaking, and then we realized, oh, someone shipped a change to the API endpoint. So we came up with this crazy acceptance test that actually spins up Octopus, load a full set of seed data, and testing against it. So every single click-driven test is actually real. Like it tests against the endpoint. It was pretty slow. It took about 5-6 minutes to run, and it doesn't feel very good to add a new test to it because adding a test to it every time means that you make the test significantly slower. Like it was in real time, like you get a slowdown of like 3 or 4 seconds with each new suite you add. So that was the problem with it, but it kind of like allowed me to sleep at night because it actually tested the whole stack from front to back. Sometimes someone would ship Octopus, make changes to the backend, and someone's branch in Dragon would break because it always pulls in the latest master to run tests against. So cemented our principle that we should always make sure that the server side is ready, like it should never break the front end. So that's kind of like helped quite a bit. So talk about some wins and learnings from it. First, separation of data and logs. Like it was one of the biggest wins we had when we switched to using a Flux model. I'm going to give an example. So we made a feature where we can log a candidate. So sometimes a candidate will be logged, and instantly the recruiter will look to her friend and say, hey, can you look at the profile, is it logged? And the profile actually isn't logged. But when you reload it, it will be logged because the next data render will show you the right state. But this is a feature where people wanted it to be live. And this is actually almost all the code we have to write to make it live. So basically what happens is we have a pusher channel that listens to the event job application change. If it changes, it will look whether it's inside the warehouse, like do I care about this candidate, is it loaded in my model? If it's loaded, it will just say, hey, dispatch an action to Flux and say, load this candidate again. So the data change actually drives the UI changes. I'm going to try live demoing this feature. So this is how our app currently looks like. So I'm going to pick the person. Live demoing. Okay. So I'm going to copy her profile and paste it in another tab. So now I'm going back to the first profile. I'm going to log her as a candidate. So she's logged on this profile. If I go to the other tab, it should be live. So this is what that bunch of code did. It basically allowed you to change the underlying data, and the data drives the UI. So it made it very simple to make this feature because the person doing the UI just doesn't worry about whether the profile is locked. If it's locked, display the right things. By the way, it's locked, but I can see everything because I'm the person who locked it, so I can see all the parts of the profile. So I'm going to unlock now before I get into trouble. So coming back to this profile, you'll see that the candidate has been unlocked, but the UI for the unlocking is still there, for locking is still there. I'll classify this as a bug. Actually, we will come to this later. So if I click cancel, I'll go back to the normal UI. So another thing that I've learned is that top-down ownership is really good. So I think in the React community, a lot of people talk about this smart components versus dumb components thing. It does work very well where the dumb components are at the bottom of the tree. So they kind of, for example, you might have a component that displays a phone number, and essentially this phone number concept is very generic. It doesn't care whether it's like the candidate's phone number or the user's phone number. It's just a phone number. So you could institute logic like rendering the phone number and formatting it correctly in the bottom component. And it is much easier to reuse this component because it is at the end of the tree displaying dumber data, where the state is like owned by a higher level component up the tree. So we couldn't exactly get drop-in kind of reuse, but we found React to be very, very composable. Like while we were trying to make the app work for our recruiters, we went through a lot of different iterations, and we have to frequently make changes while trying to get things right. And we will be able to like slice around components and put them in other places, making minimal changes, and they still work. and it was really quite easy to work with these components versus like some of the other frameworks I've used where you actually have to change a lot of like code and stuff, rename things correctly to get them to work. And the funniest thing I've learned during making these apps is that we almost have no front-end state at all. 95% of actions involve syncing with the some data on the server, like changing someone's stage or sending them an email, changing their phone number. Everything has something to do with the server. The 4% of front-end state are very trivial things like whether we are on tab A or tab B. I think all these things should be inside the URL in the first place if we can, as much as we can do it. Then the last ambiguous 1%, for example, if you're trying to save a draft message of an email the person is typing, I think a common thing would be to say like, oh, we can store it in local storage, so we will persist this value, and when you come back to that, it will render the right draft message, so the user stays his draft. But this ambiguous 1%, I think local storage is not the best UX, because if you think the draft message is very important to a user, why leave it in local storage? Why not send it back to the server and store it as part of the user domain? It's probably much safer there, and if it switches a computer and stuff, it will still work. Like, if you have a feature to save draft message, you don't want to tell the user like, oh, it's because you switched computer, or like someone flushed your local storage, or you were using incognito panel somehow. Like, we don't want to tell them this thing, we just want a feature that works. So in the end, we actually have no front-end state at all most of the time. Like, everything that we want to do has something to do with the server. And lastly, like, we almost want to reset component state all the time. We have places like the bug I showed just now, where if you unlock someone, the UI for the locking is still present. That's because that is local state. We actually don't need all these local states. Like, as much as possible, we just want to flush them, because most of the time if some action is taken out, we set things back to normal. That happens a lot. Then storing like intermediate states of UI inside. If a person taps from a candidate to one candidate and comes back to another one, most of the time it's also quite pointless to show that lock, like the lock UI is still open unless there's a message inside. So we actually have to do a lot of engineering to get the UI to show that, but it's not adding a lot of value. So like some growing pains that we face while we're doing this is like, we have a lot of missing structure, and it made us secretly jealous of the Ember guys. Like a lot of times we will discuss a problem and we'll look to how Ember solved it and try to make a simpler way of doing it that just barely solve our problems. That's how we came up with the warehouse. Like, it was trying to solve our data problems, but it doesn't do a lot of things that something like Ember data would do. And in Flux, I think a problem is something that people always say is like, you either forget to trigger or you do over triggering. Like, we render too many times. When you forget the trigger, it always causes very weird bugs where you update the data but the UI doesn't change. I think that's the worst. And because of the way we kind of architected our app, we have to find where triggers are missing and actually like add them there. And it's actually not that easy to debug. And finally, as the team size started growing, we started rotating people in the team, and no one understood the warehouse, and I got all the blame for it. So, and one of the things I've learned is like picking up intentional technical debt. Kind of like we were waiting for Relay. Relay was announced quite early on. We saw it's like, oh, hey, that's probably even if we don't use it, it's a data loading framework blessed by Facebook. I really want to see how it works. But Relay didn't come out until like 8 months later or 6 months later. I remember like I was reloading the gist every day where Vincent was explaining how Relay works and stuff. I'm hoping that it will just be released someday. And one day just appeared on Twitter, like, oh, Relay is released. But by the time we were like kind of tired waiting for it already. But because of this waiting for Relay, we avoided engineering our home-baked abstractions as much as we can. So we live with the poor data resolving behavior. Like, we don't have a promise resolving behavior. So when the UI loads, it loads the empty state first. Then when the data comes in, we'll re-render properly, but it's not really polished. We had a lot of like tiny polished bugs everywhere. And working with associations and updating data was repetitive and very tedious. And sometimes we would do hacks, like we would change the server-side response to get, because the warehouse absorbs all data, we would change the return data on the server side to make sure the associations on the front end change. I think that was really bad, but it solved our problems. Then we really learned that like our app is just data loading and mutations. So kind of like all we needed was Relay, and we waited quite a while for it. And then Relay finally landed. And I guess like a common question would be, hey, why during that months that you're waiting for Relay, why didn't you just take up arms and solve the problem yourself, or find another framework that will solve your problem? And I think the real answer is because we just didn't we weren't able to find a framework that we want to back. And taking up a framework means technical complexity. It means that you have to absorb the framework in, you have to write documentation, tell a team to do it this way and stuff. And if we did that, it would be harder for us to integrate Relay if we want to do it. So we waited, we kept technical complexity low, and just live with the home-baked stuff for now. So here I'm supposed to talk a bit about Relay. I guess as a learning point for myself, I realized that these slides covered too much of the topic, and I actually cannot go too much to Relay, and probably does not make sense because everyone will have a slightly different stack. So I'll just cover it lightly. So the thing we really liked about Relay was mutations and how decorative it was. If anyone is not using Relay yet, one of the nice things of GraphQL is like the co-location allows your queries to live right next to the view. So for example, if you had a Relay React component, like our user header right there, and if you want to use Relay, React always had this problem where props are magical. In fact, sometimes they are much more magical than state. You never know where your props come from. They always come from an outside place. Props, by definition, never come from the same component. So if you're using Relay and you had a container that wrapped around the user header, you could instantly see that this GraphQL fragment satisfied your query. It has name and email inside. It is also composable. So if you have a component that wrapped your user header, a user header is a subcomponent, you could actually coalesce the two queries together by fragments and actually run them together. So you can see that like all the navigation header needed is was the last visit date, and we kind of like put last visit date as a new data value here that's required. Oh, this works. Yeah, and the user header itself is using back its own fragment to make sure it has the query it needs. So moving to Relay, now we have to move away our Flux stores to Relay, and it's kind of like, it's very hard because the Facebook doesn't provide any help or kind of like a path for you to migrate from Flux. In fact, it's kind of like, it's also a little bit, Relay deals with server-side state, but it does not deal with any client-side state. There's no API for you to write data back into the store in a nice way. So we always thought that like because of the things we've learned, Relay is here for us to replace Flux. We no longer kind of need the Flux paradigm unless we really needed front-end state. And if we really needed front-end state and we couldn't put it in the URL, we probably would maybe one day use a library like Redux or something to do it. But right now we don't need it, so we want to kill Flux in our app. So in the typical app, we have an action to load data in component did mount. It's quite a classic thing to do, like where you trigger an action and it re-renders with the right data. And the store will actually fetch the data and pass it back to the stores. So I mean the action will fetch data and pass it back to the store. And at this point of time is where we can have a chance to integrate Relay. So we kind of want to do it iteratively and don't break any features. Make sure that we load data via Relay in component did mount instead of using the Flux action we saw just now. But continue populating the Flux stores, because one of the hard things of doing Relay is that you have to write quite a bit of code to get data to load. They say, yes, this component is now Relay, but in order to make changes to like the data, to mutate data, you have to write mutations. So like doing them both at one go is kind of tiring. So we want to do it iteratively where we can ship data loading to Relay and then change something that uses Flux actions to mutations. Then we finally swap out the actions for mutations and it will be done. And this bonus thing we learned was that like kind of acceptance tests don't really care if you're using Flux or Relay because it's a fully click-driven test. It just shows you what's broken in the golden path. So that actually helped us a lot. Then lastly, right, the challenges we faced with doing this was just the initial pain of setting up a GraphQL endpoint. It's quite heavy for a team to take up because there's a lot of things you need to set up and expose. And because we want to make sure that they are properly covered, so we write tests for them. So this actually has taken up quite a bit of time. But our whole engineering team kind of identified GraphQL as a common technology that we are trying, that it might actually be our common query language for API endpoints. For example, like the Ember team is also using GraphQL, using an adapter to change Ember data to use GraphQL instead. So on our main apps, we actually expose GraphQL endpoints for all our domain logic. And it worked quite well where I was building a hack day app and I could just get data right away. I don't need to write any server-side APIs because we use the GraphQL endpoints. And Relay documentation is really thin. So looking at the examples, I couldn't do anything at all. Like most of the examples dealt with data that was like kind of like stored in the file in the JSON hash. So it really didn't cover the whole Rails app integration. And we use this library called GraphQL Ruby that works quite well. And GraphQL Ruby Relay, which does the relay integration, but it's not documented exactly how it integrates. Like it's almost there when you just put out vanilla app, but having an example, I found a blog post that describes the process from top to toe. The blog post help a lot because there's an example repo you can do exactly how the integration is done. So I'm going to skip this. Yeah. So for future steps, we keep migrating components to relay and replace all our post actions with mutations. Then finally, we can queue with Flux because we don't really need the local state. And then queue our REST endpoints, which is powered by like active model serializers and a bunch of other things. And there's really no convention for it. Like a developer would go inside and add data if they need it. So there's no like contract to bind together. And finally, some reflections. React is great. Like, well, you guys didn't come all the way for a meetup to hear how React is great, but it is great. It has done exactly what we wanted to do, and it has never actually failed us in any way. We had some problems with it, like someone will forget that set state is async or something, but it's never something that we couldn't understand, we could learn, and there's always someone telling you that, oh, you're doing this wrong, because it's quite, library has quite a small surface area, so it's very easy to find answers you need. Webpack is great too, even though like some people might disagree. Like it kind of solved all our problems. It's like all in one packager for us that does everything. Yeah, the thing we really learned is it's really hard to engineer a good JS client app. Looking back, well, we did it, we managed to do it, and we'll continue to do it. If we were to have another team doing another app, I would advocate the same approach of using React for if it suits the purpose. And like not rewriting but building on top of things. But if I was to build my own startup, I would use Rails, Turbo Links, and React on top. Just deal with like rendering from server side. Then people build great apps, not technology or frameworks. I think there was a point of time in our team where we were very hung up on what each other are using, like the technology and stuff. But we realized that whatever that we could do that the Ember team couldn't do, we will bump the roadblock at the end. Whatever that they could do that we couldn't do, like they would bump into similar roadblocks. So everyone bumps into the same problems when building an app. It's not like the problem comes in different forms. There's no like one framework that will solve everything for you. Yeah, and finally, thankfully, we built on top and didn't rewrite. That was a big learning from us. Like rewriting is very hard. If we started from scratch and scrapped all the existing UI we had in Octopus, we probably would have failed to deliver anything at all. Then, this is just an advertisement for React. I'm using Spectacle by Formidable. This presentation is written using React on it. It was actually quite stressful to write it, but it was really fun because you could write in React and there's a live reload and everything. And finally, we are hiring. That's all. Woo! Go for it.
With Relay, were you doing any caching, or were you just doing everything with requests straight to your backend and not storing any data?
So I think we use this library called React Router Relay, and wherever Relay loads data is cached by default. So if you navigate to some place else that uses client-side state, it actually persists it for you. But most of the other are you talking about like caching on local storage or just temporary?
I'm the same thing you are. The caching function that Relay does automatically. So, because you said that you were trying to go off the back end as much as possible rather than doing state in the front end. But Relay specifically has issues where if someone else affects your server and you have something cached, it's not going to know about it.
I think so. Right now we are doing the caching because no one complained about anything breaking. Yeah, but I think the long-term roadmap we noticed this, and like mutations are actually really nice. So if you do a mutation, and if you are the only person in the world that can do a mutation, you always know the client-side state and the backend state is synced. But that's not true because someone else would be able to change your domain model. But in our app, it happens that most of the time, one recruiter screens one's job. So a recruiter will screen 1,000 candidates, and no one else will screen these 1,000 candidates. So it makes it easy for them to know that like this doesn't happen very often. But I think we want to eventually get to a place where when something happens, a live dispatch is given to Relay and it updates the cache data. So we could still use caching, but have safety that when something changes, like the front end will be notified. So that's kind of our approach to it. But Relay actually doesn't do any live subscriptions yet. So you have to basically say force refetch now.
Yeah, my question is, so you mentioned you were using Webpack and obviously you're building a single page app. And I was wondering if you ran into difficulties kind of integrating that with the Rails asset pipeline, because in building a React app on Rails, like I definitely ran into that. Rails doesn't sometimes play nice with what you want to do.
So on our Dragon app, right, we actually use Node to run Webpack. So there's no like Rails and Webpack integration. The front-end library is essentially a separate JS library. It uses Node to build everything, but then splits out this static assets. So we don't actually run into these problems. But I've seen like other projects using Webpack and Rails, and they have bumped to like problems where if you push the Heroku will not run Webpack integration for you because by default it's a Rails app. So yeah, like there are these problems. But sorry, we haven't bumped to them.
I have more general question. Like I know you guys were waiting for Relay before it came out, and you knew you wanted to use it. I was wondering, how do you usually keep up with the best trends? Like I know there's all kind of approaches. Like I have my own, and I was wondering what you guys usually pay attention to decide what's good, yeah, what am I going to use?
I guess like for us, right, because we're using React and no one else is using React in our team, so we're kind of like in the wildlands. we actually tap with everything. I had a screen with like React.js hashtag. Like every tweet, I'll look at them and see if like something interesting comes out. And along the way, a lot of libraries did come out, but not most of them were like, oh yes, this looks good. Oh, it's written by one person, and like it says hack day experiments. Like okay, we can't use this. It happened a lot.
And related, do you guys hang out in any specific IRC channels?
I used to hang out in the Slack channel, then I realized that if we switch over to this, what's that, Discord, and then I stopped following, yeah, but we have, like, I think our team, some of our team use IRC channels, but not myself.
Yep. So you mentioned that when you were using just Flux, you were able to get things to update using WebSockets, but when migrating to Relay, how are you managing to get the real-time updates with Relay? Because as far as I know, and you correct me if I'm wrong, Relay doesn't yet support WebSockets as like a first-class citizen.
So I think there's a GitHub issue on it, right? It looks very promising. Every few days someone will say something like, oh, you do it this way, but no one's committed to solving it. Right now what we're doing is just, I might get this wrong because I haven't worked on this feature for a while, but we figure out where the dispatch is coming from, and we call the right relay container to like refetch, force refetch. So it's basically kind of like, this is actually most of the time how we do WebSockets anyway. When the message just passes down, we don't use the payload because we don't want the socket message to carry too much payload. We'll make a separate request to reload the data. So yeah, but force refetch doesn't sound good.